All right, ninth graders, we are talking about solving systems using a method called substitution. So we've learned how to solve systems using the graphing method that we have done the last few days. So I want to show you this first system right here, and we are going to graph it. We are going to start by putting the first dot at +5 on the y-axis. So I go up 1, 2, 3, 4, 5, and then my slope tells me to go up 3 to the right 1, and then I can go down 3 to the left 1, down 3 to the left 1, fill in these remaining dots. And then I can connect these dots. Super fun. I'm enjoying myself immensely. All right, now let's get the second equation drawn on there. My first dot goes at +2, and then I'm going up 1, 2, 3, 4, 5 to the right 1, 1, 2, 3, 4, 5 to the right 1-ish, and then back to the middle, 1, 2, 3, 4, 5 to the left 1, 1, 2, 3, 4, 5 to the left 1, and I can connect these dots. What you are going to notice, I cannot tell exactly where these cross. It looks kind of like they cross somewhere up there. I just can't tell exactly where it is. And we've talked about how you can guess, but then you'd have to check. Does that look like they cross like at an exact point? Does it look like they cross at a decimal point? You can start guessing and checking at this point, but we're starting to see where there's an issue with graphing. Sometimes it doesn't cross perfectly at an exact dot. Also, sometimes your graph is not big enough and you need to make like your graph go hundreds and hundreds out, and that would be really impractical to make such a large graph. So I want to show you a second method where you don't need to use the graph at all. Here's how the second method works. It's called substitution. So you are going to see if one of your equations is solved for a variable. So if we look at these two equations, do you see how the top one already says y equals? By the way, the bottom one already says y equals as well, but we're gonna start with this top one, and I want you to circle all of the stuff that y actually equals. So y equals 3x plus 5. Since all of that stuff is y, I'm going to draw an arrow to the other y, and we are going to replace it there. It's almost like we're taking the two equations and setting them equal to each other because they both are y. So since this stuff all equals y, it can go in the other equation for y. All right, so when I do that, instead of y equals 5x plus 2, I can actually say 3x plus 5 equals 5x plus 2. Now I'm going to start solving this equation. So I can subtract 3x from both sides. These will be gone. And I have 5 equals 2x plus 2. I can subtract 2 from both sides. Notice how I'm keeping my work nice and neat. Please make sure you do the same. 5 minus 2 is 3 equals 2x. Last thing I can do, divide by 2, divide by 2. So I have 3 halves. I'm going to leave that as 1.5 equals x. Okay, so this is where things get really awesome because I've got half the answer. I know that this is 1.5 to the right. I just have to figure out how far up I need to count. So I am going to draw a line here, and I'm going to write down the half of the solution that I already have, 1.5. Now, I just need to get the second half. I am going to go back to that equation that I circled up there at the very top. And I'm going to write that equation down. Y equals 3x plus 5. Now remember, I already know that x is equal to 1.5. So I'm going to take this and put it in for x. So instead of y equals 3x plus 5, that is y equals 3 times 1.5 plus 5. And when I multiply that, 3 times 1.5 plus 5, I get 9.5. So y equals 9.5. So my x value is 1.5, my y value 9.5. This is called substitution method. So which method was more accurate here? Well, substitution. Here's why. because I actually got an answer. The other one I would have had to guess and then check and then guess and then check, and it would have been really ridiculous having to guess to see if it was exactly 1.5 or 1.6 or whatever. So we are going to do a couple practice examples, and I know that this is not easy for you just yet. I know that this might have even felt like voodoo or witch magic or something like that. That's okay. For now, I need you to write down what I'm writing down, and I need you to trust that I'm not making this all up, that I'm actually teaching you proper mathematics. So we're going to write down the steps. The first thing that you always do is you are going to circle what y equals or x equals. You're always going to look for either y equals or x equals. So on number 1, do you see how it says y equals 4x? There's a y equals thing. Okay, so once you've circled that, 2, you are going to plug circled stuff into other equation and solve. Okay, so where does this get plugged in? Sometimes people are tempted to draw an arrow to whatever letter they see inside the circle. That's not correct. See how it says y equals 4x? That means 4x is the same thing as y. So 4x can only replace y because that's what 4x is equal to. That's what the first equation tells you, y equals 4x. So instead of the y down here, I'm going to put a 4x in its place. When I do that, I get, instead of x plus y equals 5, that's going to be x plus parenthesis 4x equals 5. So I took that second equation and I replaced y with 4x. Okay, what is x plus 4x? Well, it's 5x. Then I can divide by 5 on both sides, and I get x equals 1. Okay, so I have half of my answer now. I know the x value is 1. Now, I am going to rewrite the circled equation. Remember how our circled equation was y equals 4x? Well, remember though, x equals 1. So instead of y equals 4x, I've got y equals 4 times 1, so y just equals 4. Okay, so step 3 was we plug the first answer into circled equation. Once we get that second answer, we are going to write coordinate answer. Write your coordinate answer. Okay, so lots of steps there. Let's go through them step by step on problem number 2. On problem number 2, I need to find something that's either y equals or x equals. Well, neither of them says y equals, but the first one does say x equals 3y plus 3. So I'm going to circle the 3y plus 3. Now, careful, that equals x. So it can only replace an x. So instead of 2x minus y equals 8, this is going to be 2 parentheses, and I've got to put 3y plus 3 in the spot where x used to be, because that stuff does equal x. Minus y equals 8. So I rewrote that whole second equation, but where there used to be an x, I put all the stuff that x equals. Okay, let's distribute this. 2 times 3y is 6y. 2 times 3 is 6. Minus y equals 8. I can combine like terms. 6y minus y is 5y. Plus 6 equals 8. Then I can subtract 6 from both sides. And 5y equals 2. Divide by 5 on both sides. And what is that, 0.4, 0.4? Y equals 0.4. So careful, that was not an x value. That was a y value. So where does that go in my solution? It goes on the right side, 0.4. Okay. Now I've got to plug the first answer into the circled equation. So instead of what x equals 3y plus 3, I've got x equals 3, and I need to put 0.4 in for y. Okay, 3 times 0.4 plus 3 gives me 4.2. So x equals 4.2. There's my x value. So my final answer, 4.2 comma 0.4. Yes, decimals are allowed on this planet. Okay, let's go to problem number 3. We need to find x equals or y equals. Dun, dun, dun! Neither of them has an x equals and neither of them has a y equals. Shucks. Okay, we are going to have to solve one of these equations then. What would be a good letter to solve for? We could either solve for this x or this y, or the bottom x or the bottom y. Which ones look like they are super close to being all the way alone? Well, the top y, all I would have to do is subtract 4x. The bottom x, all I would have to do is subtract 2y. Doesn't really matter. I'm going to choose the top one. I don't know why. So on that top equation, I know that I would have to subtract 4x from both sides. That would be gone. And this new equation is going to be y equals negative 4x. And I could write plus 0, but I'm not going to. Once you solve an equation for a letter, you cross off the original one because that one's dead to you now. You don't want to accidentally put this thing in the wrong equation. Okay, so I've got this stuff, and it needs to go in for y on the other equation right there. Okay, when I do that, I've got x plus 2, but instead of y, I'm putting negative 4x equals negative 7. Okay, so x plus, and then 2 times negative 4x is negative 8x equals negative 7. And then when I do 1x minus 8x, I get negative 7x, because those are like terms, equals negative 7. Divide by negative 7 on both sides, and x equals 1. So my ordered pair starts with a 1 for the x value. Then I need to replace that right there where there's an x. So instead of y equals negative 4 times x, I've got y equals negative 4 times 1. So y just equals negative 4. All right, there has been a lot of work that you've seen here. I want you to try problem number 4 on your own. So please push pause and try problem number 4. Okay, I'm going to start going over problem number 4. I'm going to circle everything that y equals, and remember that can be drawn an arrow to y because it equals y. Okay, so I have 2x minus 3, but instead of y, I'm doing 3x minus 4 equals negative 9. Distribute the negative 3, so 2x minus 9x plus 12 equals negative 9. 2x minus 9x is negative 7x plus 12 equals negative 9. Subtract 12 from both sides, and I have negative 7x, these are gone, equals negative 21. Divide by negative 7, divide by negative 7, and x equals 3. So my x value is 3. Over here, I'm going to rewrite the original equation, y equals 3x minus 4. Well, instead of x, I've got 3. So y equals 3 times 3 minus 4. Y equals 9 minus 4, so y equals 5. 3 comma 5 would be your final solution. All right, I want you now to let this sink in, and I want you to try tonight's homework. You'll notice that tonight's homework is not on substitution because I didn't think you were ready to practice it yet for homework. We are still going to do one more practice tomorrow where you can check your answers as you go before I have you do this as homework. So let me know if you have any questions. Yeah, move on to your graphing homework.